Hi, Michael Fry, President and CEO of Deepwater Subsea. I'm here with JD Castle, Vice President of
Score Valve Services.
And what we're going to do is we're going to take a couple minutes and we're going to demonstrate a tool that I think is very important for every guy working offshore today, and that's the Midas Meter. The reason I think it's so important is the Midas Meter helps detect leaks. And there's nothing more important, especially at that 2 o'clock in the morning scenario that I always talk about, when you're going on downtime because you have a leak in one of your systems. That leak could be from a pneumatic system, a hydraulic system, any type of valve that you have, a manifold on the rig, you need one of these tools. So what we're going to do is JD's going to walk us through a scenario, basically a demonstration utilizing the Midas Meter. And what we'll do is just kind of walk through and show where the value of it is to the guys who are working offshore. So JD, yep. Let's get into the demo. All right, so what we're going to do is JD's going to walk us through the use of the Midas Meter, and we have a simulated manifold here set up with a pneumatic leak. What we're going to do with the tool is walk through a demonstration of how you'd actually go about detecting a leak utilizing the Midas Meter. So JD, if you could just tell us a little bit about what you have here and what it is we're looking at, and how much of a leak do you think we have at the moment?
All right, excellent. But what we have is a very simple setup. We have an air source here that's generating a 40 psi pressure. It comes into the back of the demo panel. The demo panel, you can see at the top, has a gauge and also showing the 40 psi pressure. This pressure goes all along the top and has no way to exhaust downward into the exhaust chamber right here, except going through these valves. What we've done, we've selected one valve, created a small leak in it, and we'll utilize this tool to determine which one of the 5 potential leak paths is actually leaking. And we have a flow indicator here on the backside to show that there is actually flow coming through as well.
Cool. Well, let's go ahead and get into it.
This right here is the actual Midas Meter itself. It's a very simple, very ruggedized, with a lot of certificates that shows the actual output reading. I'll turn it on right here. And we've taken a lot of complex math from hundreds of thousands of data points and created algorithms and generated it all down to a number. That number is right now 22. 21 and 22 are your typical background noise indicators, your 0 point if you would. And that's actually the frequency coming off the computer board inside the unit. What that number represents is a decibel reading, and based on the leakage going through the valve, it will turn into a decibel reading, and that'll tell us the intensity of the leak. So right now what we'll do is we'll go through and check these valves. And again, up there is the gauge indicating 40 psi. The air comes through and it has 5 potential paths to go and exhaust out. You can see here on the right, there is the flow indicator, that there is air actually going through it, but very, very small amount. So we'll take the actual unit and we'll start on the left side or the right, it doesn't matter. Start right here and I'll push down. Yeah, take the button off, thank you. That's an actually good time to, the whole feature is in case we are in a position that I can't read the background indicator. I can push the hold button and it'll freeze it, so when I pull the unit back in my range, I'll be able to see what it is. So we'll put this over here, and it looks like we have a reading of 25. That's 25 decibels. Now that tells you that that's above the 21, 22, so initially you might think that's leaking, but it might be propagation from another valve leaking going that direction. So you need to check other valves as well. Okay. This valve here is up to 27, so we know that it might be further upstream. So let's check the next one in the line.
Well, it's a big difference between 25 to 27, so now we're at 40.
Up to 40, 39, so that looks like that's pretty high. I would place my bet there, but it might be even beyond. It could be up to 50 here and just propagating down, so let's take a look. No, it goes down to about 27, 28. And again, this valve looked like it was, wow, 48. And then 27, let's check the one on the end just to confirm. And we're back down to 25. So we have basically a 24, 27, 42. So this is the valve that's actually doing your leaking.
Well, that's really interesting. So basically just from a simple putting the meter on it, a very small leak, 40 psi, you guys can pick up the harmonics, I guess is what it is, as it crosses through the valve.
Absolutely. What happens is the seat itself has a small a hole in it, and it's generating where frequency vibration. As the air liquid median goes through, it causes the valve body on the backside to vibrate in a frequency that we can't hear, see, or touch. The frequency is between 60,000 and 600,000 hertz. This device listens to that. Another benefit of that is, since it only picks up at the beginning 60,000 hertz, there's no noise, interference, or anything on the platform that would possibly blend into this one's sensor. So this is total. If this hears something, it's a leaky valve. And also a side note, this material we put on here is just to help the contact and make sure we can pick the signal up. Because when you're talking about 400,000 to 500,000 cycles per second, it dissipates very quickly. So we want to get as good a contact as we can.
No, it's amazing. I think the best thing about this tool is for subsea guys, for mechanics, for anybody out in the field, if you're having to troubleshoot, especially the subsea guys in the discipline that we deal with the most, what you find out is, hey, there's a valve in the choke manifold leaking. Well, what do you have to do? You have to isolate one valve. You have to pressure back up.
Yes.
No, it wasn't that valve. Let's go and redo the lineup. With this, troubleshooting is very simple. You walk up with the tool, put the tool up to the valve, get a good reading, and you actually get a baseline ahead of time using some of the other things that we'll talk about later.
Yeah.
But what you can do is you get that baseline. You have a valve that you think is leaking. You just walk up there and start taking your points. And as we demonstrated, very quickly, seconds,
Yeah.
you can figure out what the leak is.
Absolutely.
No, it's fantastic. It's fantastic. Well, good. Well, I appreciate it. You know, this is something that I think everybody should have on their rig. It's something that, you know, us at Deepwater Subsea, our guys are going to be carrying with them as they go out and you know, provide support. And we appreciate JD and the team here at SCORE for giving us a demo of it.
Oh, thank you so much for the opportunity.
Appreciate it.